We've seen that things will dissolve in each other, and now we're going to look at this a little more closely. Mixtures can be solutions, colloids, or suspensions. A suspension is heterogeneous because it has large particles suspended in the solvent, and they're so large that eventually they'll settle out. An example is blood. It's got blood cells suspended in the plasma. You've got flour that can be stirred up in water, but eventually the flour settles out. Colloids have much smaller particles. Colloids do not settle with time, and if you get it dilute enough, you can see a beam of light shining through it because the light gets bounced off the particles. Some examples are milk, fog, and then we have solutions. Solutions are intimately mixed so that they're homogeneous, and you can't ever see a beam of light in it. You can see through the liquid. It's translucent. Sugar and water, oxygen and air. Remember that the solute is a smaller quantity and the solvent is a larger one. When we have solutions, we already know that like dissolves like. Water is polar and would dissolve polar compounds. So ionic compounds will dissolve in water, and polar covalent molecules will dissolve in water. And we know that nonpolar things will dissolve nonpolar things. Ionic compounds dissolve in water. And when ionic compounds dissolve in water, they make ions that are separated out and dispersed in the water. Because they make ions, they allow water to produce electricity. Pure water actually does not conduct electricity. It insulates electricity. But if you just have a teeny tiny amount of any ions in there, then it will conduct electricity. So anything that produces ions in water are called electrolytes. Electrolytes are acids and salts. Acids you can recognize because the formula starts with hydrogen, and salts you can recognize because they're either going to be metals with nonmetals, or they're going to have ammonium in the front of the compound. Here are some examples. All of these you can recognize as being acids because they start with a hydrogen. This is hydrochloric acid, sulfuric acid, and acetic acid. Salts you can recognize because they're a metal with a nonmetal, metal with nonmetal, metal with nonmetal. This is a salt because it's an ammonium compound. Non-electrolytes are those things that will dissolve in water that are not acids and salts. These are going to be the compounds that are small, like oxygen will dissolve in water. Polar molecules that are small, or compounds that are no more than 3 carbons to each nitrogen or oxygen. So right here, this is the formula for ethanol. It is water soluble because there's only 1 oxygen to 2 carbons. This is glucose, 6 oxygens to 6 carbons. We can recognize those as being water soluble because of the oxygens, the numbers of oxygens present. So the rule that like dissolves like continues to hold. Polar dissolves polar, nonpolar dissolves nonpolar, and we know how to identify what is polar based on non-bonding pairs and the groups on the outside. So how do electrolytes dissolve? They do this by dissociation. We learned that sodium ions will become hydrated and chloride ions will become hydrated. When we put solid sodium chloride in water, it's a little crystal lattice. But as the water starts bumping into it, what happens is the sodium and the chloride ions separate and become hydrated. This is called dissociation. Here's a picture of hydrated sodium, negative oxygen crowding around the positive sodium. And this is a chloride ion being crowded around by water molecules. Notice the positive hydrogen is all close to the chloride. So now what I want you to do is draw a picture of the hydrate that would form for the calcium and hydroxide ions when you dissolve it in water. Well, the first thing you would have to do is draw the two ions. Here's calcium, and here is its charge. Notice you have to show the charge. Unless it's charged, it will not dissolve in water. Here's a water molecule. What part of this water molecule is going to be attracted to the calcium? It's going to be the negative oxygen end. So we'll draw several of them around the calcium ion like this. Negative closest to the calcium. Hydroxide has a negative charge, so water's positive end will be attracted. Bring it in and crowd it around the hydroxide. Solutions can be either saturated or unsaturated, and this has nothing to do with double bonds. What it has to do is what is the maximum that can dissolve. There's a maximum amount of sucrose that you can put into water. If you have less than that maximum, we call it an unsaturated solution. If you have all that it will contain and there's more solid in at the bottom of the container, then that's called saturated. Most solids increase in solubility as the temperature increases. And of course, all gases have decreased solubility with higher temperature. But if we change the pressure, a solid has no effect or a liquid has no effect on its solubility. Only gases are affected by changes in pressure. How is it they get large amounts of carbon dioxide into a Coke, so when you open it up, it starts bubbling and releasing the carbon dioxide? The way that they do that is they pressurize the Coke solution and pump in the carbon dioxide. The higher pressure gives it higher solubility, so that you'll have lots of that bubbly effect that people seem to like in sodas. We will quantify our concentrations, and most concentrations have this format that the concentration is equal to the amount of solute over the amount of solution. Notice this says solution, not solvent. The solution is the solvent and the solute combined. Percent concentration is a very common way of expressing concentration. We'll see this in hospitals. 5% dextrose, 0.9% sodium chloride. Percent means per 100. So per 100, we already know per means divided by, so it means divided by 100. If we look at 35%, well, that then means 35 ethanol over 100 solution. So to make that, you would take 35 grams of ethanol if you're doing a weight for weight solution, 35 grams of ethanol, and then 65 grams of water, and that combines to 100 grams of solution. And so then we know that if you got 100 grams of solution, there would be 35 grams of ethanol in there. When you look at a percent concentration symbol, it often will have WW or W/V or any of these symbols right here. And what this is telling you is how it was prepared. W for W over W means weight for weight. W over V means weight per volume, and V over means volume for volume. So 35% weight for weight means that everything was measured in grams. If it's 35 W over V, that means weight per volume, so 35 grams in 100 mils. And if it says V over V, then it was 35 milliliters in 100 mils. And so it's really telling you how it's prepared. the concentrations between these different ways of preparing it actually would differ slightly. I want you to know what ppm and ppb stand for. ppm stands for parts per million. So if it says, let's say, 20 parts per million, then that means there were 20, the ratio was 20 to 1 million. So to prepare a large quantity, you would do 20 grams in 1,000,000 grams of solution. If it says ppb, well, then it's in 1,000,000,000 grams of solution. Now, when they make them up, they don't make them up this, that size solution, but that's a ratio that you would have between the solute and solution. When we use these things, it's usually for very, very dilute solutions. We are not going to be doing any calculations with percent, parts per million or parts per billion. What I want you to do is be familiar with what it means. How much in how much.